Welcome to iLecture Online, and here's another example of how to work with matrices. And in particular, we're going to find the inverse of a 3 by 3 matrix. Now, to find the inverse of a matrix, the matrix must be what we call a square matrix. It must have the same number of columns as it has rows. So we can do this for a 2 by 2, a 3 by 3, a 4 by 4, and so forth. Now, when you get bigger and bigger, this becomes a very long and tedious problem. So 3 by 3 is very doable. And the technique is that you recopy your matrix, like so, but you allow some room for a second matrix to be placed right next to it. So you recopy the matrix here, and then over here you put what we call the identity matrix. An identity matrix is a matrix with ones across the diagonal going from upper left to lower right and zeros everywhere else. And now we're going to go through a series of steps in such a way that when we're done, the matrix to the right that started out as the identity matrix will then turn into the inverse matrix. So this will eventually become the inverse matrix of the original matrix. And to do that, what you do is you go through a series of steps to make the left one look just like the right one the way you started. You want to make the left one into an identity matrix. You want this to be ones across the diagonal and zeros everywhere else. And there's a set of rules that you have to follow, and I'll show you the rules. They're very simple. The first thing you want to do is you want to start with the upper left corner, and you want to turn that into a 1. To do that, you take this whole row right here and you divide it by 2 to make the 2 turn into a 1. Of course, whatever you do to this element, you must do to all the elements in the very same row. And the way you note that is you say you take the first row and you replace it by 1/2 the first row. So you multiply the first row by 1/2 and replace the existing row that was there. All right, let's do that. So this whole row is going to be divided by 2, so this becomes a 1, a 1/2, a 1/2, a 1/2, 0, 0, and everything else stays the same the way it was before, 1. All right, we're part way there. We got a 1 where we want it. Of course, we don't have everything else yet the way we want it. So the next thing we want to do is get rid of this and this. We want to turn this into a 0, and we turn this into a 0. So the two things you can do is you can multiply an entire row by number, or you can multiply the row that has a 1 in it by the negative of these numbers and then add it to the row so that that number will disappear. What did I just say? What you can do is you can take the second row, R2, and replace it by the negative of this row, so -3 times the first row, and add it to the second row. So what happens is, if you multiply the first row by a -3, this becomes -3. If you then add it back to the 3, then that becomes a 0, and that's exactly what we want. We do the same over here. We take the third row, and we replace it by the negative of this number, which is the -2, multiply times the row that has the 1 in it, which is the first row, and then add it back to the original row, the third row, and then this 2 will disappear. So now you'll have 2 zeros there. Of course, you'll have different numbers for all these other elements in the matrix, but that's okay. We'll get there later. First, we want to get those 2 to be zeros. So when you implement that, what do we get now? Well, notice that top row doesn't change. So we have 1, 1/2, 1/2, 1/2, 0, 0. So the top row doesn't change. That's the one with the 1 in it. That's the one we use to get rid of the other numbers. So now we take -3 times R1, so -3 times 1, and add it to the second row. That becomes 0. Of course, since you did it to this one, you have to do it to all the other ones as well. So -3 times 1/2, which is -3/2, added to 2 gives me a positive 1/2. -3 times 1/2 is -3/2, added to 1 gives me a -1/2. -3 times 1/2 is -3/2, added to 0 is -3/2. -3 times 0, nothing changes, so that stays a 1. -3 times 0, nothing changes, that stays a 0. All right? Third row, -2 times the first row. So -2 times 1 is a -2, added to 2, that becomes a 0. -2 times 1/2 is -1, added to 1, that becomes a 0. -2 times 1/2 is -1, added to 2, that becomes a 1. -2 times 1/2 is -1, added to 0, it's -1. That's a 0, so nothing changes. That's a 0, so nothing changes. All right, we're 1/3 done. We have the very first column in the manner that we want. A 1 there and 2 zeros there. So now we work on the next two columns. We start on this column right here, and we're going to start out by making this into a 1. To make that into a 1, we have to multiply the entire row by 2, and that will then become a 1. So I'm going to take R2, row 2, and replace it by 2 times row 2. Simply what we're saying is we're going to multiply the second row by 2. When we do that, we get the following result. Okay, now nothing else is changing. I'm only changing row 2, so row 1 and row 3 remain the same. So I have a 1 here, 1. Okay, so the only thing we're going to do here is take the second row and multiply it times a 2. So that means we get a 0 there. This becomes a 1. This becomes a negative 1. This becomes a negative 3. This becomes a 2. And that becomes a 0. So notice I took the second row, multiply every element by 2, and that gives me the new row. Now, I succeeded in making this a 1. I have to make those 2's zeros. Now, since this is already a 0, I only have to concentrate on this one. So I'm going to go ahead and turn this into a 0. And how do I do that? I'm going to take the first row, R1, and replace it by the negative of that number, minus 1/2, multiply times the row that has the 1 in it, which is the second row in this case, so R2, and add it back to R1. So you always take the negative of the number you're trying to get rid of, multiply that times the row that has the 1 in it on that particular column, and then add that back to the original row, and this will become a 0. Of course, you have to do that to all the remaining elements as well. So let's do that. In this case, row 2 doesn't change, so we have 0 and 0. Row 3 doesn't change, 0 and 1. But now row 1 changes. Now this cannot change because there's a 0 here, so that stays a 1. So we have negative 1/2 times R2. So negative 1/2 times a 1 is a negative 1/2. Added to 1/2, that becomes a 0, which is what we wanted in the first place. Now we continue on the rest. Negative 1/2 times a negative 1 is a positive 1/2. Added to a positive 1/2, that becomes 1. Negative 1/2 times a negative 3 is a positive 3/2. Added to 1/2, that's a positive 2. Negative 1/2 times a 2 is a negative 1. Added to 0 becomes a negative 1. And this, since is a 0, that doesn't change. All right, we are now done with the second column. We only have one more column to go, which is the third column. Now, the first thing I would want to do is make sure that this is a 1. And since it's already a 1, I don't have to change anything there. I can leave it alone. So the next step would be to get rid of these two right here. You want those to become zeros. So again, the technique is you take the first row here. You look at this number. You want the negative of the number. Multiply times the row that has the 1 in it and add it to the original row. And I said, well, wait a minute. Doesn't that one have a 1 in it? Yes, that's true, but the objective is to get diagonals here, all to be a 1, and those are the ones that you're going to use in order to get rid of everything else, make zeros of all the other elements. So again, you're going to take R1 and replace it by the negative of this number, negative 1, times the row with the 1 in it, which is row 3, and add it to the original row 1. And for the second row, you're going to take the second row and replace it by the negative of this number, which is a positive 1, times the row with the 1 in it, which is R3, and add it back to the row that you're trying to eliminate the number of, R2. All right, let's go ahead and do that. So let's see, which row did not change? The one that has the 1 in it, which is the third row, so that stays the same. So you copy that one down. All right, now for the first row, negative 1 times the third row. Now, of course, since these are zeros, that means those two elements don't change, that they stay there. Okay, so now we have negative 1 times a 1, which is negative 1, added to 1, that becomes a 0. So negative 1 times a negative 1, that's positive 1, added to 2, that becomes a 3. Negative 1 times the third row, that's a 0, so nothing changes here. And negative 1 times R3, which is here, so negative 1 times that is a negative 1, added to 0, that becomes a negative 1. Okay, one more row to go. Again, since these are two zeros, nothing changes here, so this is a 0 and a 1. So 1 times R3, 1 times this is 1 added to negative 1 becomes 0. 1 times negative 1 added to negative 3 becomes a negative 4. 1 times 0, nothing changes, that stays as a 2. 1 times 1 is 1 added to 0 becomes a 1. And we're done. Here now, on the left side, we have what we call the identity matrix. That's what we have started with on the right side. And notice that this matrix on the right side turned from an identity matrix into something different. And this here is called the inverse of the matrix A, which is how we write it, A to the minus 1. And to find the inverse of A, that's what we're trying to do. You found it by taking the matrix, joining it up with an identity matrix, go through the process to make this matrix look like this matrix, and what you end up with on the right side is the inverse of the matrix A. So, just to make sure that we did everything correctly, there's a way to check that out. This is our original matrix A, and this is our inverse matrix A to the minus 1, or A inverse. If I multiply matrix A times matrix, or the inverse of the matrix, I should get back the identity matrix. Identity matrix looks just like that. So let's go ahead and try that. Let's multiply these two matrices together to see if we get back the identity matrix. If we do, we have the correct answer here. You can imagine it's very easy to make a mistake somewhere, so that's always a good way to check. So let's start with the original matrix. So we have 2, 3, 2. And we'll multiply that times the inverse of the matrix, the way we found it. So 3, negative 4, negative 1, 1. All right, let's see what we get. So the way this works is when you multiply two matrices together, is you multiply the elements of the row on the left times the elements of column 1 on the right. So it's 2 times 3 plus 1 times negative 4 plus 1 times negative 1. So this becomes 2 times 3, which is 6. 1 times negative 4 is minus 4. And 1 times negative 1 is minus 1. Okay? So that, of course, goes into the first element right here. So 6 minus 4 minus 1, that's a 1. So far that looks good because that's what we want right here. Okay, so now for the second element right here, for the second element, we multiply this row times this column. So we go 2 times negative 1, which is negative 2, 1 times 2, which is a positive 2, and 1 times 0 is plus 0. So add that together, so this is equal to 1. Add this together, you get 0, which is correct. That's the element right there. All right, next element. To get this element right here, we're going to multiply this row times this column. So we get 2 times negative 1, negative 2, 1 times 1 plus 1, 1 times 1 plus 1. And you can see negative 2 plus 1 plus 1 is 0, so we get a 0 over there. So far, things are looking good. All right, to get this element right here, we're going to multiply this row times this column. So it's 3 times 3, which is 9. 2 times negative 4 is minus 8. And 1 times negative 1 is minus 1. And you can see that 9 minus 8 minus 1 is 0. So we get a 0 over there. So far, so good. To get this element right here, we're going to multiply this row times this column. So it's 3 times negative 1, negative 3. 2 times 2, which is plus 4. And 1 times 0 is plus 0. And as you can see, this equals 1. So we get a 1 over here. All right. Next, we multiply this row times this column to get this element right there. So it's 3 times negative 1, which is negative 3. 2 times 1, which is plus 2. And 1 times 1 is plus 1. And you can see that this is equal to 0. And we get a 0 there. It's beginning to look really good. Again, you want to get the identity matrix when you multiply the matrix times its inverse, and so far we're looking really good. Let's try the last row now. To get this element, we're going to multiply this row with this column. So it's 2 times 3, which is 6, 1 times negative 4, and 2 times negative 1. That's negative 2, which is, when you add them together, sure enough, that's 0, which is what we wanted. Okay, now to get this element right here, we're going to multiply this row by this column right here. So it's 2 times negative 1, 1 times 2, and 2 times 0. So you can see that's negative 2 plus 2, that is 0, so we get a 0 there. And finally, one more, if we're correct here, the answer is correct. So to get this element here, we're going to multiply this row by this column. So 2 times negative 1 is negative 2. 1 times 1 plus 1, 2 times 1 plus 2, and sure enough, when we add those together, we get 1, which is 1 right there. And we can see that when we multiply this matrix by what we thought was the inverse, we get the identity matrix, so therefore it is correct. This is indeed the inverse of the matrix A.